sometimes we have to use as I told you, whatever, wherever we have written the definition. For example, union, A union B. As we know that union means A union B if any element belongs to A union B. This means you should remember these things. X belongs to A or X belongs to B. Okay. So these points you have to remember to solve that type of question. So I am taking one question. Prove that in which difference, intersection, and union are involved. Prove that these types of questions we have to solve by using the properties. Uh, Prove that A minus B intersection C is equal to A minus B, and it will become union. Union A minus B union A minus B. Okay. So solving of these questions are quite different. So we will take one arbitrary element which will belong to this, and at last by using the property we will reach to this. Okay. So whenever we have to prove is equals to, so what we have to prove, suppose we have to prove A is equal to B. So what we have to prove, I told you before also, we have to prove two things. First, X belongs to A, we will take first point X belongs to A and use some properties, and we reach to the point B. X belongs to B, which implies that A is the subset of B. Okay. Then second time we will take another element. So well, let Y belongs to B and we use some properties to prove that yes, Y belongs to A, which shows that B is a subset of A. So from first and second, when you prove A is a subset of B and B is a subset of A, then you can prove A is equal to B. So from first and second, we get A is equal to B. So this is the way of proving two in that theory. This is called set theory actually. Set theory, or that we are going to prove A is equal to B, so we have to prove two things. Similarly here, A this equal A minus B intersection C, we have to prove equal to A minus B and union A minus C. So first we will take an element. Let we start with X. So let X is an element which belongs to A minus B intersection C. B intersection. Okay. So on broad distribution, first we will write this. This negative sign will be removed, and this is these all the property I am again writing so that you can easily refer again. If X belongs to A minus B, that we have seen in difference, this means X belongs to A and will come, and X belongs to A and X does not belong to B. This property will be used. So if you will remove this negative sign, so we get X belongs to A and X does not belong to B intersection. Okay. Yes. Very important thing. When we have X belongs to A union B, we used to write X belongs to A or X belongs to B union. Or if it is intersection, we will write and. But when the opposite we get, suppose X does not belongs to A union B, then this will imply, because union is what? Or. Then or will change into and say for example, I'll write here whatever the thing I'm writing here. X, if X does not belongs to A intersection B, does not belong. If it is belongs to A intersection B, it will become X belongs to A and X belongs to B. But when it does not belongs to, then and will become OR, because this is the opposite of this. So this will mean that X belongs to A, intersection is AND, so AND will become OR. X does not belong to B. Okay. So similarly here this again will be splitted according to the definition. So we can write here X belongs to A and is outside. Huh? This should be written inside the bracket. So these all the operations. So we should care about it when we are going to write the distribution of AND on OR, something like that. So distribution X does not belong to B, and this is AND. Intersection is AND, but here it is does not belong to AND will become OR. So we will write X does not belong to B. Okay. Now this X belongs to A will go inside this bracket. So obviously it will be written X belongs to A and X does not belong to B, or X belongs to A and X does not X belongs to A and X does not belong to B. Means and is distributing on OR. This is the distributive law. What? This is distributive law. This portion will multiply inside. You can say with this. First you will write with this. So it will be written as X belongs to A and X does not belong to B. Okay, first part. Then OR will come. Then OR will come, and again this X belongs to A will go with does not belong to C. So X belongs to A and X does not belong to C. Okay, you should remember these things, then you can do it easily. It is not a big task. Now, as I told you, minus, what is minus? A, X belongs to and X does not belongs to B means X belongs to A minus B. So see, this is the definition of minus. So now we can write together these two. We can write X belongs to A minus B. This means X belongs to A minus B. Okay. And then or अपनी जगह पर है as it is. And here also we can write X belongs to A minus B. A minus B. Okay. And when or is there, or will convert into union. If you want to write together this all X belongs to A minus B or X belongs to A minus C, so this will become when or we will remove or will become union. A minus B, X belongs to A minus B union A minus B. Now you can see we got the right hand side A minus B, that is A minus B union A minus B. So this is what we have proved. Therefore, we got this is a subset of A minus B intersection C is a subset of A minus B union A minus C. Okay, so this is our equation number one. As I told you first, now second part we will do second part. Now we will take right hand side. So again let there is an arbitrary element y which belongs to A minus B. Opposite of this, actually all steps will be reversed from, if you see the reverse steps you can write. So A minus B union A minus Now first you will write A minus B and union also, everything you can write in this step. Minus means Y belongs to A and will come. Where and will come, where or will come, this you should remember. And Y does not belong to B. Okay, minus is converted and union means or, and again here Y belongs to A and will come. Y does not belong to, Y doesn't belong to C. Okay. Now you can see that Y belongs to A and Y belongs to A and this is the reverse of the distributive law. We can take it out common. So we can write Y belongs to A and, okay. When you take this common, what will be left in the bracket? This will be left. You can see this part will be left, or will be left, and Y belongs to C will be left. So what we will write, Y does not belong to B, or Y doesn't belong to C. Okay. Now we can also write Y belongs to A, Y belongs to A, and Y, when Y does not belongs to B, does or will convert to, and all will convert into intersection. So Y does not belong to B intersection. Whereas I told you, when intersection, when does not belongs to is there, then intersection will convert into or, and union will convert into and. So we get and, now and convert into intersection. So we can say that Y belongs to A, not intersection, does not belong, minus, because and does not belong, so it will convert into negative. So A minus B intersection C. So from, you can see that this is the subset of this one. So we prove that A minus B, A minus B union A minus C union A minus C is a subset of A minus B intersection C. This is our equation number 2. So from first and second, we prove, from first and second, we get A minus B intersection C is equal to A minus B union A minus B. So this type of equation we have to prove. For proving, we have to do like this. So there are many proving things are there. Now we will see disjoint set. Disjoint, as you can see from its name, disjoint means they are not joined. Means they don't have any common elements. That's why they are called disjoint set. When they have no common element, then their intersection will be a null set. So if two sets are said to be, two sets A and B are disjoint if and only if A intersection B is a null set. Okay. So this mathematics we use IFF, but it doesn't exist in English. IFF means if and only if. So for short form, if and only if we can use it. Okay. So intersection is a null set. So obviously, how we will draw its Venn diagram? Null set means there is no common element between them. So we can draw its Venn diagram so that the two sets there should be no common element. This is your universal set. Our universal set. Okay. Then two sets. Set one we can draw anywhere, and set two we can draw anywhere, but they should not have any common portion. So these are the disjoint set, Venn diagram of disjoint sets. Okay. Then complement of a set, complement of a set. So for defining complement, we should be given universal set because the rest of the elements of that set are complement, called a complement. So complement if U be a universal set and A be any set of universal set. Hmm? So then universal set is required. So let U be a universal set and A be any set. A be any set which is a subset of this universal set. Is a subset of this universal set. And A be a subset of this universal set. Then the complement of A with respect to this universal set. We say complement of A, complement of A with respect to this universal set U is the set of all elements, is the set of all elements which are not the set of all elements of universal set which are not in A, which are not A. And it is denoted by two ways. Complement of A is denoted by complement of A is denoted by we can denote by two ways. Either we can write bar on A or A dash. Generally A dash we are using A dash. It is very important. Okay. And how we will define does A dash or complement of A dash is a set of all elements of X such that X belongs to universal set, but and X does not belong to A. So this is what when we are proving, we prove the previous question using these properties. So A dash means except universal set. So if we want to show this one, So this is a set. Suppose this is set A. So its complement will be outside this whole portion. Outside this means this whole portion. This outside this portion. Then say this is outside A. This whole portion is of the universal set is okay. Got it. This all portion. So we want to show this complement of A. So outside we have to just state outside portion. Full outside portion in the universal set will represent this. Okay, like this whole portion will represent the complement of set A. Okay, so this is the complement, and now some properties of we have some properties of complement of sets. Very important. Then we have De Morgan's law. So some some properties of complement of a set. Some properties of complement of a set. Of a set. Few properties are there. Number one, complement of a complement is a set itself. Complement of a complement is a set itself. Okay. And what is A? A is union. A is equal to universal set minus complement, called law of double complement. Second law is divided into two parts: A union A complement. A and its outside area full, if we will take, it will become universal set. Universal set. This is universal set. And B part is, if you write A intersection A complement means outside portion, inside portion, so there is no common portion. So that will be the null set. And the third property is the complement of a null set is a universal set, obviously. And similarly, complement of the universal set will be a null set. Okay. So Z fourth property, A union B. Complement of A union B will be equal to universal set minus A union B. That is the same that we have defined for complement. Here it is defined for union. Then we have De Morgan's law and their proof. So I will write here De Morgan's law, then we will have some questions. So the very important laws, De Morgan's laws. Actually, there are two laws, and it is also called theorem. De Morgan's theorem, sometimes theorem or law. Which the statement is, if A and B are any two sets, if A and B are any two sets. This is actually giving the relation between the complement of the union and intersection. So are any two sets, then two sets. Then first, if you find the union of two sets, first you find the union of two sets and then its complement. So it will be the same as you find the complement of the sets separately and their intersection. So the simple way of remembering this complement for union A union B complement will become intersection of their complement, and similarly opposite of this is A intersection B complement. When you take the complement, this union will become intersection will become union. So A complement union B complement. This is De Morgan's law. We can represent by Venn diagram also, and we can prove these two theorems also. So first we will prove we will prove that A union B complement is equal to A complement intersection B complement. As we are proving together, we can take x1, y1, x2, y2 because we need we need more. Okay, we can take any, no problem. X belongs to, let's take an arbitrary element. X belongs to A union B complement. Okay, then complement means X does not belong to union A union B. Then X does not belong. X does not belong. Complement means does not belong. If X belongs to a complement, then X will not belong to A. Okay. And if X belongs to A, then X will not belong to its complement. If X belongs to any set A, then X will not belong to its complement. Because complement is outside area. So therefore X does not belong to, and union will become into, when it is does not belong to, then union is or, but it will become into and because of does not belong to. So X does not belong to A, and union will become and X does not belong to B. Okay, and as I told you, if X does not belong to A, then X will belongs to A complement. So X will belong to A complement and will not change, and X belongs to B complement. And this and you can write together also, X belongs to A and B, A and B. And means intersection. So X belongs to A intersection B. So it is proved that A union B complement is a subset of A intersection B. The first part has been proved. Now we will take second part. So right hand side, let A complement intersection B. Let's take any element Y which belongs to A complement intersection B complement. Okay. So this implies the intersection means and. So Y belongs to A complement and Y belongs to B complement, implies that Y does not belong to A and Y does not belong to B. When it is belonging to complement, it will not belong to the set, and this N will become union, as I told you, because does not belong to X. So X does not belong to A union B. When it is not belonging to A union B, it will belong to its complement. Y will belong to A union B complement. So proved that we get A complement B, A intersection B complement is a subset of A union B complement. Second equation, from first and second we got the result. from first and second. A union B complement is equal to A complement intersection B complement and prove. So by this way you can prove another law. This is the first law I proved, the first part. Second part is second part I write here. Do not get confused. The second part is we have to prove A intersection B complement is equal to A complement union B complement. So this is your you can do by yourself for proving this one. Same way that I did like okay. So this you will prove. Now we have finished our topic. So this is topic 4. So now we have exercise next time. Then last topic will be left and last exercise will be left. Okay. So now we will do the exercise next time. Tomorrow we have 2 periods, so we will do exercise and then maybe new topic will be started. Okay.